One of the most common uses for the Pythagorean theorem is to find distance between points. This video will show you how to find distance between 2 points on a graph using the Pythagorean theorem. Here we have 2 points, the point 2, 4 and the point negative 1, 1. 2, 4 is right there, and negative 1, 1 is right there. That line indicates the distance between those 2 points. I can't simply count the boxes because they go through the boxes diagonally. However, I can go sideways here along the boxes and vertically here along the boxes to make a right triangle, and this side is 3 long, this side is 3 long. I can use the Pythagorean theorem to find the length of this side simply by saying 3 squared plus 3 squared equals that distance squared. 9 plus 9 equals d. So 18 equals d squared equals d squared. The square root of 18 equals d. And I'll need my calculator for this one. And then I would get 4.2 equals d. So that distance I would round to 4.2. This technique involves you to actually draw the points on the graph and make the triangle. Can it be done without a graph? Well, let's see. So here's another point. 1, negative 2. 1, negative 2 goes here, and another point 4, 2, which is right here. And let's draw that line. There's my distance. Now, like before, I have this triangle. But let's talk about what this triangle means. This line right here is in the x direction. It is really the distance between this x value of 1 and this x value of 4. 1 and 4. The distance between 1 and 4 is 3. And as we can see here, that distance is 3. Now this line right here is the distance between the y value of negative 2 and the x value of 2. Negative 2 and 2. We can see that that distance is 4 and that distance there is 4. So I would have 3 squared plus 4 squared equals my distance squared. And as I would work through this Pythagorean theorem, I would get 9 plus 16 is equal to d squared. 25 is equal to d squared. The square root of 25 is equal to d, so 5 is equal to d. Let's try that without drawing the graph at all. Here are my points. 4, -1, and 8, 5. The distance from 4 to 8 is 4. And the distance from -1 to 5 is 6. Now at this point, some students sometimes like to know if there's a mathematical operation that can be used to find the distance. And there is. I'm really just subtracting. 8 minus 4 is 4. 5 minus -1. Oops. 5 minus -1. Well, that's the same as 5 plus 1, as 6. Now, when you're finding a distance, though, you don't really know which point goes first. You could end up here with 4 minus 8, and that equals -4, or -1 minus 5, and that equals -6. These are the same except for their negatives. Now, if you think about it, distances can never be negative. So if I get a -4 or a -6, I can just disregard that negative number. So I take these and I put it in my Pythagorean theorem. 4 squared plus 6 squared equals my distance squared. So 16 plus 36 is equal to my distance squared. So that becomes 52 is equal to my distance squared. So the square root of 52 is equal to my distance. And now I'll need my calculator. Take the square root. And so I have 7.2 is equal to my distance. Now let's come back here. When I got negative distances, which you really can't do, distances can't be negative. That would, instead of having a 4 squared, I would have a -4 squared and a -6 squared. Well, when you square a negative number, you always get a positive number. So even if I was to work with these negative numbers from my distance, my formula would come out exactly the same. Now, if you look in a math textbook, you will find this distance formula, where d is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. x1 minus x2 is just finding this distance. So this whole thing would become 4. y1 minus y2 is just finding this distance. So this whole thing would become 4 as well. So I would have the square root of 4 squared plus 4 squared. You square those and have the square root of 16 plus 16. Have the square root of 32. These are all equal to d. And again, I need my calculator. 32 square root and so d is equal to 5, and I would round that to 0.7. This is really the exact same mathematical procedure as we did in this one. I squared things, I added them together, I took the square root. I squared things, I added them together, I took the square root. I don't like this formula simply because it looks intimidating to students. having it written out like this can just be frightening and turn students off, when really all you're using is the Pythagorean theorem, which is quite simple. If the distance form, if you find this intimidating, don't worry about it, don't use it. But you do need to know that in later math classes, you may have a teacher or an instructor who has assumed that you've seen this formula because you've found how to find the distance between points. Don't worry about it. You know how to find the distance between points. This formula is just another way of writing that.